Dear 7th graders, Mrs. Oliver here, bringing you today's lesson that is in our Chapter 6, Lesson 1 of the textbook, solving one-step addition and subtraction equations. Okay, so this is the start of our huge part of equations. All right, we've already learned our one-step equations with whole numbers. That's something you should have been doing last year. Maybe instead of an x, maybe you had a question mark put there before. Okay, maybe you've seen something like this, 5 plus something equals 9. Maybe that's something you've seen before. Okay, now all we're doing is taking that question mark and putting a variable there instead. Okay, so our objective today is that I will solve one-step equations. We're going to start off with just addition and subtraction, and then we're going to move on to multiplication and division. What's different from what you learned last year is now we have our lovely negative integer and rational numbers we're going to use. And the reason why you need to know this is because then our next section is going to be two-step equations. We got to start off with baby steps and then keep on working our way up. We're going to be taking some notes today, so if you didn't print out the notes, get out your notebook to take these. Okay, we have our first set is 1, 2, 3, 4, and there's 2 more, 6. 6 examples we're going to do, so you know about how much room you're going to need. Okay, so we are going to model our one-step equations first. And then with each one, I will show you how we do it with algebraic steps. Okay, so first one, on one side of our plate here, I have an X. Okay, it's all by itself, just one little lonely X. Then it says I have 2 positives. So you can put your positive signs like this, or if you like rather, you can go that way, whichever you prefer. I like the plus and minuses, or the ones are really easy to draw while I'm using the smartboard. So let's just go, I'm going to use the plus sign though for now. So let me erase these 2 off. I have 2 positives, and you'll see later why I want to do that. Okay. So next I have on the other side of the equal sign 6 positives. All right. There's my 3, 4, 5, and 6. I have 6 positives. But my job here is to get this X all by itself. We want to, as we call it, isolate the X so that we know what only the X will equal. Okay, so the only way I can get rid of these 2 positives is by taking the opposite of it, 2 negatives. And then whatever I do to this side on the left, I have to do the same to the other side, or it's not the same equation no more. And the reason why we do that, remember zeros that we talked about before? They cancel each other out. Those are my zeros. And the same thing over here. I now have some zeros. So my X equals whatever I have left over. So we would say our X equals 1, 2, 3, 4. Okay. So what we get over on the left side, we should get the same over here on the right side. Okay. So the algebraic way is I want to get rid of this positive 2 by using its opposite. Okay. So we want to subtract 2 on both sides. And notice how I'm lining it up. And then I put a line to stay nice and neat. Then if you need to, another lovely little extra step is knowing you're crossing those out. It has now disappeared on me. So then I bring my x back down, because we didn't get rid of that. That's still there. So is my equal sign. And then I just have my 6 minus 2. Well, we know 6 minus 2 is 4. That part's easy. We also now are going to check our solution. The way we check our solution is by taking our answer of 4, put it back in the equation. And remember how we last week checked solutions to find out if they worked, if they were true or false? This is what we were preparing for. So is 6 equal to 6? Yes, it is. We are good. Check mark, we are good. If you need to, pause us and then come back. All right, now we have y equals a negative 5 and 8. So I'm going to put my y, and we want to get this y all by itself. That's what I'm looking for. And then I have 5 negatives. I'm going to switch to a red to represent my negatives. 1, 2, 3, 4, 5. Okay. And then let's switch to a bluish color. I have now 8 positives over here. Put my 8 positives. 4, 5, 6, 7, and 8. Well, what's the opposite of our negatives? Well, a positive, right? That's the only way we can zero them out. So I put my positives. I'm going to have to probably switch which side each one goes on, just so that they're lined up right. Remember, these make zeros. Using the mouse. Those are all zeros. Now, whatever I put over here, I gotta do over here. So I gotta put 5 more of these plus signs. You know what? 1, 2, 3, and there's 4. 1, 2, 3, 4, 5 more plus signs. So how many plus signs do I have total? Well, we would say now that y, because x isn't the only variable we use, is equal to 13. That is how you model it. Okay, that is as important to know as doing it algebraically, which we're going to do over on the side. I'm going to show that I'm going to add 5. I'm going to add 5. I'm going to put my line. I'm like, well, if I owe you $5 and I give you $5, I owe you nothing. And then y equals, if I had a number line and started at 8 and took 5 more hops to the right, I end up at 13. Okay, so now my job is to check my work. I gotta take 13 minus 5. Use my number line again, start at 13, take 5 hops backwards. I end up where? I end up at 8. So does 8 equal 8? Yes, it does. So we give it a big check mark because this solution is true. Okay. Now we have some with a couple negatives on one side, negatives on another side. I'm like, oh my goodness, I got a lot of negatives going on. But that's perfectly fine. All right, so I'm going to put my P. Remember, we're trying to get P isolated. It's got to be quarantined all by its lonesome. And I'm going to put 7 negatives. 1, 2, 3, 4, 5, 6, 7. Then over here, I'm going to put 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Yes, I count those out so I don't lose track. Okay, I want to get this p by itself. Well, how do we make zeros? We make zeros by using the opposite. And the opposite of a negative is our positive. So I'm going to turn each of these into positives now. Remember, then they make zeros. So that means I really have only my p left on this side. Whole point of doing it. Because we can't just take away. We have to balance it out. And whatever I did over here, I now got to put 7 plus signs over here. So there's 1, 2, 3, 4, 5, 6, and 7. So what's left over? I only have this left over. What was 3 negatives represent? P then equals -3. Okay, if you need to pause that, I'm going to go over to the side and I'm going to show you how to arithmetically, algebraically show this to you. I need to get rid of this whole number right here. This is what I'm trying to get rid of. So that I only have my P left. So I'm going to add 7. And whatever I do to one side of the equal sign, I got to do to the other side where it's not even anymore. Now, if we were in person right now, you would see me tipping over like I'm a teapot, showing you how to keep it even. All right, if I owe you $10 and I give you 7, how much do I still owe you? Well, I still owe you a -$3. And it's negative because I owe. Owing money is not good. All right, so this is where some students might make mistakes checking the work. Like, oh wait, but -3 minus 7, can we do that? We have to do that lovely word, remember? Adding the opposite. We gotta come back in here and add the opposite. Then we can follow our integer rules. You have 2 negatives, you decrease twice on our number line. So then we do get a -10 equal to a -10. So yes, our solution of -3 does in fact work. If you need to, pause that before we go to our fourth one. Okay, so here I have 4 plus x equals -9. Well, I know easily over here, I could put 9 negatives, 2, 3, 4, 5, 6, 7, 8, 9. That's easy to know. But what is this for? Is this a -4? Is it a +4? There's no negative in front of it, so it is a +4. We have 4 positives over here. And of course, we still have our x that we want all by itself once we are done. How do I get rid of these positives? Okay, I want to cancel them out, make them zeros. So I gotta put some negatives in here. Okay, because then they make zeros. So then I'm only left with my x on this side, and what is my x going to be equal to? Well, I got to put those 4 negatives over here. How many negatives do I have in total when I'm done? I have 9 here, 4 there. So that means I have a -13. Okay, so that's how we would model it. All right, next one. I need to get rid of this 4. And this is where a lot of students will be like, ooh, I'm just going to add 4. No. There is no negative sign here. You're going to assume it is a positive. Okay. Now, this one up here is the same as a -9 minus 4. But we have to come through and add the opposite to really make it -9 plus a -4. Okay? That's what we're really doing in this little section. Okay? So, going back. Oops. I now can figure out, okay, so these cancel. I'm only left with my x. And I have equal, a negative and a negative, same signs, add and keep, make a negative 13. Check my work. Checking work does not take that much time out of your life. Always check your answers. Then those little silly computation errors that we make aren't going to be such a big deal. All right, if I have $4, but I spent 13, I might get an alert from my bank telling me, hey, you owe $9 more. And is -9 equal to -9? Yes, they are. So our answer is good. We need to pause that and then come back for our last two examples, and then we'll start the homework. All right, so this is why we have algebraic ways of solving it. Do you really want to put 300 negative signs on one little tiny square? It's not going to work very easily. So this is what I did for modeling it. I actually put 50s. Okay, so then I know I'm going to come into here later and I'm going to set it up that I have positive 50s. Okay, so these are what I started with. That makes a negative 100, 200, 300. Now I'm going to add. So what that makes is this is now canceled along with one of these. So then what's left? Well, I only have 50, 100, 150, 200, and 250. So we would say S equals 250. Okay. So how would I do here? It's adding a negative. Well, instead of adding a negative, I want to add a positive 300. We're going to do that to both sides. Add 300. Now remember, always do your best to underline because it makes it easier. So I have just my S and my equal sign. Well, if I owe you $50, but I made $300 today. After I pay you back, I only have $250 left. So let's recheck our work. Is 250 plus a negative 300 equal to a negative 50? Oops. Well, if I do my math right, we get negative 50 equals, oops, equal to a negative 50. Yes, in fact, this does work to our liking. Okay. Questions on that one? Make sure you make a note of it to ask your teacher. All right. So then same thing with this one, except now look, I want to get rid of what's over here by subtracting my 94. Just because it's on one side doesn't mean you're gonna. So then now you look, ooh, I have two negatives. Same signs. Add and keep. There's my x. So the same signs I had to keep. So 7 plus 4 makes 11. 9 plus 3 makes 12. And then that becomes a 3. Okay. It's doing the same thing as with our modeling. So then I would check my work once again. Check it. Put it in here. I'm going to shrink this up now. Okay. So I have a negative 227. And I want to put that equal to negative 321 plus my 94. Okay, well, that means I actually need to subtract those because I have a negative and a positive. After I do my math and I subtract them, I get that yes, our solution does in fact work. We are good. Okay. All right, if you need to, pause this, come back, and then we are going to start the homework. So you might want to open that up in your Kami document. Oh yeah, I had to compare and contrast. All right, so what do we have here? We have two different equations, right? One is subtracting, so that's what makes that different. And then this other one is adding. That's what makes those different. But they both have an x, and they both are equaling a negative 11. All right, so how would I go through to solve it? They're both one-step equations, except one gets a positive 6 and the other one gets a negative 28. So whether you are adding or subtracting, that does make a huge difference of what your actual answer to your problem is going to be. That's why it's important to know what operation you need to do to cancel out and make those zeros to get your variable isolated. All right, now let's start the homework. Okay, so for the first 4 problems, we need to do like we did in our homework. We're going to model and we're going to then algebraically solve it. Okay, so let's start with 1. I have an x. I'm going to put my 6 negatives. Since I have a positive 2, I'm going to switch to a blue for a positive. Okay. All right, so I need to cancel these out so that I can figure out what x is when it's isolated. So remember, the opposite of negatives is a positive. So I put my 6 positives here. Guess what? Whatever I do this side, I gotta do this side again. So there's my 2. And I'm not gonna be able to cancel anything on the right side because of that. So then once we're done, I have how many positives left on this side? I have 8. So we would say our x equals 8. Because remember, these are zeros, so they all cancel each other out. All right, algebraically, we need to solve this now. And so this is a plus 6 because of this negative here. And whenever I do that side, I gotta do this side. Bada bing, bada boom. And so then x equals 8. But then don't forget, we have to check our work. So we're going back in and we're going to check it. So I'm plugging 8 for x. That's why we practice those expressions. And we're at a negative 6. So it's like saying I have $8 and I spent $6. We want to know, does that really equal $2? Well, put 8 ones in front of you and take 6 of them away. What do you have left? You have $2 left. Okay. Even though some of these are very simple, you need to still check your work so that when we get to those 2-step equations, you know what you're doing. Okay, so you're going to do that the same with 2, 3, and 4. And then when you come to this side, you're going to have more that are just showing your work. Remember, show your work, check your work. So let's go through this together. Okay, so I want to get rid of this 24. There's nothing in front of it. So I'm really going to put a minus 24. And then I'll put minus 24. And then put your line underneath with a W equals. And then you're going to subtract these, but I have to do some regrouping. So this is really a 6, and this is really a 12. 12 minus 4 is 8. And 6 minus 2 is 4. So we're saying that our solution is W equals 8. I always write it that way. You don't want to leave it up here how they have it. Okay, so let's check our work. Take 72 equal to 24. And if I add 48 to that, what do we get? So we want to know that yes, 72 does in fact equal 72. Okay. Only ones I would say look out for. Okay. Make sure you're paying attention whether you have negatives or positives. Okay. Same signs add and keep, different signs subtract. Now this time, what's the opposite of your negative? You're going to actually want to add 15 to both of these. We're going to add 15 to that side, not 16. I'll start this one off with you, but you will need to finish it yourself. Okay, I can get it to line up 15. And then you're going to need to add 15. There we go. So that is how you're going to set up that one. So then finish solving it and then turn your work in. All right.